Okay, guys, we are on page 8, continuing on with our circles unit. And we are looking at how to find equations of circles if we have certain pieces of information. And if you'll remember from yesterday or the day before, that we had the equation of a circle as x minus h, all of that squared, plus y minus k, all of that squared, equals our radius squared. So if we're given different pieces of information, such as a point on the circle and the center, point on the circle and the center, we're going to have to find the length of that radius. Or if we're given the endpoints of a diameter, we're going to have to find the midpoint to find the center, and then we're going to have to find the distance of the radius. Okay? So we're going to look at different ways of doing that. Okay? Our first method is using the distance formula. It is here written out for you in red. It is the square root of this entire expression, x minus x of 1, all of that squared, plus y minus y of 1, all of that squared. That is distance. We have another method that we will be showing you, or I will be showing you here in just a second, where we are going to take the center and replace it in the equation for h and k, and then the value of the point on the circle, we're going to fill that into our circle equation for x and y. Then we're going to do some calculations, and we are going to find the value of r squared. And once we have the center and our radius, then we can rewrite our equation and go about our business as usual. So I'm going to show you both ways. I need you to stick with me on this, okay? Because it's going to be done two ways. I'm going to have to kind of make some room on the paper, and we will get started on that. All right, so first we're going to use the distance formula in the example where we are given a center of positive 3, negative 4, and it passes through the point 6, 2. So we would have a circle, with a center of 3, negative 4, and we would have a point on the circle that is 6, 2. That's what this problem looks like. We need to find what is that radius in order to fill it into our equation at the top. All right, again, stick with me. There are going to be two methods. The first one is using distance. The second one is going to be using the substitution method, and they are both laid out here, but I want to show you how they work. All right, given our x minus x1 and y minus y1, I want to find those two pieces and label them first. So in my problem, I am given a center and a point it passes through, and I'm going to write them in column form so that I can label them and keep them straight. So positive 3, negative 4, and the point it goes through is 6, 2. So this is center, this is point. Just going to label them out to the side. Okay. Now, I'm going to label them x and x1, y and y1, so that I remember where they need to go in my equation. Okay. So, my distance formula equals big square root. May have to extend that if I write big. First part, x minus x1. 3 minus 6. All of that in parentheses squared, plus y minus y1, negative 4 minus 2, all of that squared. Okay, so we now can start the calculation of the distance, keeping the square root. 3 minus 6 is going to be negative 3, but negative 3 squared is 9, plus negative 4 minus 2 is negative 6, but negative 6 squared is 36. So I'm going to move that over into the next part of my equation. Do that calculation. It is still underneath the radical. It is still the square root, and that is 45. Okay. Final step to reduce the radical. That 45 breaks down into 9 times 5, and 9 breaks down into 3 times 3. The radical rules. 3's get out of the doghouse, or pairs get out of the doghouse, so 3's outside, leaving 5 inside the doghouse. And that is my final answer for the length of the radius. Okay. That is using the distance formula. I'm going to use the second method here, where I substitute the center for h and k, and the other point for x and y, in that original equation of a circle. And it's up to you to pick whichever one you like, okay? But I will show you both of them, all right? So my original circle equation, and I will put that, write method 1 here, and then method 2 here. I'll go ahead and highlight those. And my equation of a circle. I'm going to make it a little smaller so it all fits. A little more. X, point x6, minus the x coordinate of the center, 3, in parentheses, squared, plus the y of my point 2, minus the y of my center point, squared, equals r squared. So 6 minus 3 is 3. 3 squared is 9. 2 minus a negative 4. These turn positive. So 2 plus 4 is 6. 6 squared is 36. Okay. So now we've got 45 equals r squared, guys. Okay. So now the difference between the answers I get is this is r and this is r squared. Okay? So one is the radius, one is the radius squared. Either way, I can put it back into the equation of my circle formula, which is where I want to get to. So I'm going to make that in purple. So x minus the center point squared plus y minus the other center, turning positive, squared, equals r squared, or I can square this radius. Either way, it is going to be 45, and that is my final answer for the equation of the circle given a center of 3, negative 4 and a point on the circle of 6, 2, using either the distance method or the substitution method. Okay. Yeah, it's a lot. Oh, yeah, we'll get through it. So if we are given the endpoints of the diameter, and let's do a circle over here. So a diameter goes through the center and goes side to side. And we have a radius on one side, we have a radius on the other. Right in the middle, that midpoint of the diameter is that center. So that's why we're going to use the midpoint formula. So endpoint x plus other endpoint x divided by 2, comma, endpoint y plus other endpoint y divided by 2 is going to give me the coordinate point of that midpoint, that center. Okay? So let's do that. We will do the equation of a circle that has a diameter with endpoints 4, -5. I'm going to label that x and y. And -2, 3, and I'm going to name those x1, y1. That'll help me keep track of what I'm doing when I'm going to my midpoint. So find the center. We're going to use the midpoint formula. So x4 plus x -2, all of that divided by 2, and y -5 plus +3 divided by 2. That goes to 4 plus -2 is +2 divided by 2. And -5 plus 3 is -2 divided by 2. And reducing those fractions turns into 1, -1. This is center. Now then, I need to figure out from the center to one of these 2 points is going to give me my radius, right? Because now I have this one -1, and I have either the first point, left point, or the other right point. It doesn't really matter which one, because from the center to the edge is always a radius. So you know what I'm going to do? I am just going to pick the first one. Okay. So 4, -5. And I am going to do the distance formula for this one. No particular reason. The substitution method would do just fine. You know what? On second thought, I am going to do the substitution method because frankly, I like coming out with r squared. I don't have to take it all the way down to radius because I really want r squared. That's what I'm looking for in my equation. So let's work smart and not hard, shall we? Okay. So now what I want to do is the length of the radius, okay, using method number 2. Okay, so that second method was to substitute the values of the center and one of the points. Okay, again, 4, -5. This is the point that I'm going to use. So, oops, let me write that a little better, guys. Okay. I could just as easily have used -2, 3. Pick a point. Okay. So, x, y, h, k. So, x4 minus h1 squared plus y, -5, minus -1 squared equals radius squared. That turns into 4 minus 1 is 3. 3 squared is 9. 5 minus -1 turns into -5 plus 1. So that's -4. -4 squared is 16. And that equals r squared. Finish off that calculation. 25 equals r squared. Now I have my center. I have my r squared. I can go and fill in my equation up here. Okay, so let me do that in purple. So x minus h, all of that squared, plus y minus k, minus a -1 makes that positive. All of that squared equals r squared, which I already figured out is 25. So that is my final answer, given the ends of a diameter, to finish the equation of the circle.